So in the last video, by now we brought our deployment to the point where we have a customer environment running and we have the infrastructure for the metered billing accelerator running, but we did not yet look into exactly how the metered billing accelerator internally works. So now let's get this particular part going. So just as a reminder, in the customer subscription, we have a first version of our app deployed, where we can, for example, submit usage from the virtual machine. And now we want to see how that usage is used inside our ISV environment here. In order to do this, I executed an additional script on my system, which is inside the scripts metering shared resource broker. It is called the setup local dev principle script. So with this script, I augmented the whole environment and added a dedicated service principal credential, so I can run the metered billing accelerator also locally on my machine, on my development laptop here. Usually for production, we try to use managed identity wherever possible. But right now, using a service principal here can simplify things a bit. So let's get this started. So first of all, in my environment, after running the setup script, we're basically collecting a bunch of environment variables and writing a script, this set development environment, which inserts these configurations into our Windows environment here locally on the machine. So let's just have a look at what my concrete configuration on my machine looks like when it comes to these variables. So set on Windows shows me my environment variables, and I grab for Azure metering. So let's have a look at these variables and do a quick walkthrough what the individual environment variables mean to me. So, and let's move them, and here you actually now see client secrets from my demonstration environment and tenant IDs and stuff. And of course I will change these things so that they are not really usable or sensible for an attacker later. Let me just pause the video and order this a bit. Okay, so after I ordered these values a little bit, let's have a look at what they are for. The Azure metering marketplace tenant ID and the infrastructure tenant ID, these are basically the same value. They point to the ISV or to the publisher Azure AD tenant. Then we have two credentials, and I made the distinction here between a marketplace client and an infra client. The marketplace client, as a reminder, is the identity which is authorized to submit usage data to Azure Marketplace. So as a short reminder, when we go to the Azure application we published into the marketplace in one of the previous videos, and we look into the technical configuration of the offer, we can see the identity. So this here, the technical configuration of the offer is the identity of the managed application that will be able to emit metering events over here. And you see this 48F4 identity. This is exactly the same thing what we have here. In addition to this, we have an infrastructure client, and this infrastructure client, this infra client ID, is an identity of which is authorized to work with the resources in the ISV environment. So this identity has data access to the storage account and can also read and write to our Azure Event Hub here. So these are just two different identities, one for Marketplace, one for the infrastructure, but of course you could also use the same service principal, for example, or managed identity for both of these things, right? So let's just have a look at how this fits into the bill. For example, let's look at the event hub, at the concrete event hub instance. And inside that instance, once we have the metering instance, we look into the access control. And there you can see in the role assignments, here, let me just make this a little bit to the right. I created this particular application here, that thing with the name principal at the end. This is effectively the my development service principal. So you see there are two owners. Owners can read and write, so to say, or publish and subscribe to Event Hub, which is the accelerator's managed identity when I'm running it in Azure, but also a dedicated service principal I'm using for development purposes. And of course, on the sending side, without the capability to read from there, we have the security group of all the service principals of the deployed managed applications, right? So this would be an example how the infra client kicks in. Then we have some configuration here related to where are artifacts stored. So we have a so-called snapshots container. This container in our storage account contains all these snapshots which are generated by the metered billing accelerator, or by the aggregation component. So you see the snapshot the snapshot generator constantly writes to the state snapshots, and these state snapshots are configured here. The checkpoint container is something which the Event Hub client needs for synchronization. So when you run multiple instances, the checkpoints container is used by the Azure Event Hub SDK as a synchronization primitive, so you can ignore this one. And then we have the Event Hub configuration. So we have an Event Hub namespace. So this is our whole namespace, and in this namespace we have a metering instance. And we also configured Event Hub capture so that all the messages which we send into Event Hub also show up as Avro files within this capture storage account. And here I basically specify the names for these files. So you can see, like, based on, for example, partition, and so partition ID, year, month, day, hour, minute, second. These files are organized in the capture container. The last thing which is interesting is recently I introduced two new configurations. So the max duration between snapshots and the max number of events between snapshots. So what are these two terms? What are these two terms doing? So let me just create a short screenshot here of that thing and bring it into, let's bring this in here. So the snapshot generator has to figure out how often it serializes the partition's overall configuration with all these subscriptions in that partition into a JSON file in the state snapshot. We certainly do not want to create a blob in blob storage or a new update. We don't want to write to blob storage for each message which hits Event Hub. That would be a burden. But at the same time, we do not want to snapshot every 1000 messages, because then when the aggregator restarts, it has to reprocess all these messages since the last snapshot. So we need to find a good balance between how often do we want to snapshot. And in this case, for example, I'm saying, like, every 5 minutes or every 10 messages, what comes earlier of these two events basically results in a new snapshot file, assuming that something has changed. So if we just take a very brief look in what's inside this storage account, let's just peek around this one and see what's going on. So inside the storage account, we have the different containers. And when I look in the snapshot container, so under the name of our event hub namespace and the instance, we do have different names, so it looks like different folders for the different partitions. When you think back to what these partitions are about, is we use the identity of a managed application, or also of a SaaS offer, as a partition key when we submit messages into Azure Event Hub, right? So the question is, what do these messages, what do these partition keys look like, and how can we find out where they are, to which partition they are sent to? So when we SSH back into, as a customer, when we SSH back into the virtual machine which we created yesterday, and I'm just going to print out the metering information, I do have here the managed by property. So this here is the partition key, or the resource ID under which, the resource URI, under which the metered billing accelerator knows about this particular running managed application. I added inside, there is a bin folder inside the repo, and inside this bin folder is a Linux and a Windows application which is called partition ID. So when I call partition ID, it tells me that I can specify a partition count. So let's just have a look at how many partitions did we had in here. This partition, this event hub instance, let's look at the concrete event hub here. The metering event hub has 13 partitions, right? So we say 13 partitions, and the partition key, the partition key, first of all, can be anything, right? So if the partition key would be Christian, with 13 partitions, a message sent to partition key Christian would end up in partition number 3. But our partition key is not Christian. Our partition key is this thing here. So let's just paste that one here and see in which partition our messages end up for this particular subscription. And the tool tells me these would be ending up in partition number 11. What's now worthwhile to know is that for each partition inside Event Hub, we have exactly one state file representing this partition's state in the state file. So let's just have a look at what's going on in partition 11. So back to our storage account, into the snapshot container, containers, and then snapshots, into the name of the event hub, the name of the concrete thing, and then partition 11. In here, we can see various state files corresponding to different partition numbers. And the thing which I'm now interested in, these are basically intermediary snapshots. And the thing I'm interested in is this latest JSON thing. So this is basically a gzip compressed JSON file. So when we download this file and we open up the file in, after decompressing it, let me just do this here for a sec. Let's just do this. So we go to the downloads folder and we gzip. Do I have gzip on? Oh, I do have gzip locally, gzip-decompress, and then latest JSON. And now we open latest JSON in a text editor. You can see the actual payload. So here is basically the data for the subscription with a given resource ID. and we can see our plan information, the billing dimensions which we configured yesterday, the short names like dimension A, but also the official names under which these things get sent to Microsoft, such as demo video dimension, pure pay as you go, or the unlimited thing, and so on. Right? So this is the latest snapshot. So okay, back to our back to how can we run this here in our local environment and see what's going on. By the way, one thing which I didn't mention, this WSL-env is effectively a way to trickle down Windows environment variables down to a WSL session. So when I'm running commands in the Windows subsystem for Linux, all these Windows environment variables are visible inside WSL as well, which is just a neat trick, so to say. Okay, but back to our desktop metered billing accelerator, and let's have a look in the top directory. Yesterday I created a small Docker Compose file here, and this Docker Compose file uses the latest official image of the metered billing accelerator from Docker Hub to just boot up an instance of the metered billing accelerator, and I'm just passing down all the environment variables in. So this means when I'm running here something like Docker Compose up, we can locally in my Docker for Desktop environment see a copy of the metered billing accelerator booting up. So let's just give it a minute. So this thing now uses the service principal information for these two service principals, metering API and infrastructure, to connect to Event Hub Capture, and to the storage account, and helps us look into, it basically starts crunching through the data. Or even better, let me just run that thing here in Docker for Desktop. I just hit the OK button over here. And this should now be spinning up the container. And over time, we can now see it loaded state for different partitions. So partitions are initializing. The aggregator is taking ownership over the different partitions to read from there. And for example, we can see that it loaded state for partition number 7, it loaded state for partition number 0, for partition number 13, and so on and so on. So, and this here is a quick visualization of which partitions are owned by the current metered billing accelerator instance. So you can see that partitions 0, 1, 2, 6, 7, and 10 are owned. And over time, each time when you see something like partition initializing 8, 5, and 3, these basically get added to the mix. So whenever I do a print statement here, I can effectively see which partitions are owned by the aggregator. So now, this is kind of the fully synchronized, fully jiggled up state, where I know our partition 11, where the data from this particular managed application is in, and also all the other partitions are now owned by a single metered billing accelerator instance. So now that we have the instance running, let's actually go back to our virtual machine and submit some usage information again. So remembering we called these dimensions internally dimension A, B, and C. So let's say there is something happening for dimension A. So we have a consumption of 1 unit for dimension A. Let's send that message towards the metered billing accelerator. And what you could see down here is at the current time it says a new event arrived. This syntax here, 1 # 46, means In partition number 11, the 46th event in global order in this partition arrived, and it also saved the state for this particular partition. So let's do it again. Let's send some usage in for dimension B. And again, event number 47 arrived here. And let's do something again and say we want to watch that thing happening. So every 2 seconds, we are now emitting information, and you can see as soon as a message gets appended to Azure Event Hub, to the Azure Event Hub partition number 11, all these values basically get aggregated into the current metered billing accelerator instance. So let me just pause that thing here and have a look. So inside the scripts folder, so mount C users Geuer desktop metered billing accelerator. Inside this folder, inside the scripts folder, I have a bunch of shell scripts which effectively help me to peek around inside content, right? So for example, I can say, show me a meter collection. Show me a meter collection for a certain partition. So I can now, for example, say, show me the meter collection for partition number 3. And because this is a completely fresh instance, partition number 3 has no meters included, like the meters collection is empty. And we know our partition, the one which contains our, the subscription of the managed app, is in partition number 11. So let's peek into number 11. And here we can see the meters collection contains exactly a single entry for our particular subscription here, right? So this here was a subscription, right? So let's check what scripts we also have. I can say, show me a meter. So I want to see the meter for this particular customer, so to say. And it gives me the more fine-grained information. I can also say, show me a meter value. In particular, I'm interested in dimension-A. And what these scripts effectively do is they take the ID, the resource ID or the resource URI of the customer purchase. They map it to a partition ID with a little partition ID utility, which you saw earlier. Figure out the total number of partitions, get access tokens, and so on, and basically download the most recent state snapshot from the blob storage and show me the content. So for example, here we can see that there was a total of 95 units of this dimension A basically already used inside the system. Okay. Another thing which I would like to show is more on the .NET and F# side of the house. So let's open Visual Studio. And inside just to orient ourselves a little bit in the .NET solution. So these things down here are basically core libraries. Inside the application folder, I have the aggregator component. This is literally the thing which is currently running in the Docker container, and the shared resource broker, which is our REST endpoint down here. So this is the shared resource broker REST endpoint. And I have a couple of command line tools, such as replay capture for partition. So what this replay capture for partition utility is doing is it is going out and downloading all Azure Event Hub capture files all of them from the storage account and saving the corresponding JSON payloads to the local file system and re-executing the business logic. So this tool here gives us a complete audit trail of what happened in a system. If that doesn't directly make sense, let's just Control F5 the whole thing and see what it's doing. And I hope it's coming up on the right screen. Let me just pause until the compilation is done on my laptop here. Okay, so now the executable started here on my machine. This will now read the environment variables and connect to the Azure Storage account to the capture, and you can see it's reading all these capture files and printing out information about, it's partition 3, 4, 5, 6, 7, 8, 9. These are basically just ping messages, and we will see in a minute what these ping messages are about. Here for partition 11, it's doing a little bit more and spitting out more information, and now that's done. So what just happened? Let's just look at it from a file system perspective. So inside source, tools, where is the tool? Inside source, why don't I see? No. Hold a sec. I just didn't find the tools thing here. And then inside replay capture for partition, when we go to the bin debug folder in .NET 8, there is a data folder. This was created by the utility. And let's just look at the data folder for partition number 11. And let's zoom out here a little bit and let's make this one here go away. We don't need all these things. Here, inside this folder, we can see that for partition 11, a bunch of events came in. For each event, for each message which hit event hub, we can see the resulting state out of this message. So remember, this is an event-sourced system where a new message, a new event, and the old version of the state create a new version of the state. So when the system boots up, like at position -1 if you like, it starts with an empty state file. And the first message which our managed app has sent yesterday afternoon when I purchased the application was this subscription purchased message. So the subscription purchased message, it included the managed by property as a resource URI. It adds a local timestamp from the function or from the job, right? It is a monthly subscription, and so this information here is, you might remember, coming from the plan JSON, which we packaged in our managed application, right? So in our managed application, we had the plan JSON, and this is effectively the same information now coming here in as the subscription purchased message. And this is sent from within our deployment when the application is purchased. The result of this message hitting an empty aggregator instance is effectively the aggregator populating the meters collection with the first meter, which is exactly the one which we had here, with all the data about the plan and so on. And inside the plan information, we can now see a slightly different data structure, because it now has information about when was each meter updated for the very last time and what's included where and so on. So let's see what happens when we now start using the solution. When we executed the script for the very first time, like the submit meter script, we said there is a usage of dimension C of 1. And this resulted in this message. And the dimension C1 now has to make a state change on dimension C. And you can see it here. The included quantity is infinite, but even though we record that it consumed one entity of this infinite amount. Then we have dimension C of 2. So 1 was already there, 2 additional consumption, resulting in a consumed entity of 3. Having usage reported for dimension C of 1 again, 3 plus 3 from here plus 1 is 4. Also, like, and on it goes, right? So we have a dimension B. And dimension B is now slightly more interesting, because for dimension B, this is a pay-as-you-go dimension with a limited amount of quantity included. So the included quantity in the previous file for dimension B was 10 and consumed was 0. Now that we consumed one of those from dimension B, we can suddenly see that the actual meter value says that 1 is consumed, 9 are remaining. So let's see dimension 1. This is basically referring to a non-existent meter here, so it doesn't really change the state at all. Dimension A, this is the first time we see dimension A. And we now have a total quantity of, and a consumed quantity of 1. The total value basically aggregates over the whole billing months. The consumed quantity is the amount in the current hour. So this here, this change came in at 1444 UTC yesterday, right? So it means between 2 o'clock and 3 o'clock there was a used quantity of 1. And the way the meter billing accelerator works is each time it sees a new message for a particular partition in a new hour, it knows like there cannot be any additional values coming in from the previous hour. Like if I get a new message at 1 minute after 3 o'clock, I know that nobody can send in any information for the time window between 2 and 3 because the clock already passed behind 3 o'clock. And it's important to note, like, the aggregator or the accelerator does not use wall clock time like the local computer's clock, but it relies on Azure Events Hub for actually providing the clock signal. Okay, so the event of dimension A1 basically bumped up this counter. And now an interesting thing is happening. So yesterday I stopped the aggregator. I just, killed the process. And you can see like there is this gap between like me sending a message at 1444, which was this one here. And then I stopped the accelerator. So I didn't aggregate stuff, but maybe there have been messages at Event Hub coming. In this case, no, nothing did happen in Event Hub. And then I restarted the accelerator. I just Control F5 the whole thing and it booted up again. And what the accelerator does is when it starts, it sends itself a ping message. And the reason is starting because a new instance has started. These ping messages have the purpose of kind of flushing the system, if you like. The ping messages are sent basically by the emitter into Event Hub as well and show up in the business logic. And each time the business logic can see a ping message, it basically gives us information about the time stamp within Event Hub, like what is the current time in Event Hub. Okay, so when we look at the old state, we can see that there was included quantity or consumed quantity for the time between 2 and 3 o'clock. And at 7:52 in the evening, the aggregator, got started again. And the business logic is now able to say, okay, it is 7 o'clock in the evening. There cannot be anything happening more between 2 and 3 in the afternoon. Therefore, I can reset the consumed quantity, at 1952. I can reset the consumed quantity back to 0. The total for the billing month remains 1. But what happens, with, our consumed quantity 1 gets reset to 0? What happens to the data? Well, this information basically makes it into a new field inside the data structure. So the usage to be reported collection here is effectively a to-do list of all the data that is supposed to be submitted to the metering API. So thinking back here, the business logic basically says nothing can arrive anymore for this hour which already passed. Therefore, I can total it up and package it in a to-do list. And the emitter component here in the aggregator says, oh, you want me to send something to the Azure Marketplace Metering API? Well, I am happy to do so. So the emitter takes all these usages to be reported, like this one, and this is literally the API call. It's basically saying like, hey, this part, let me just wrap the whole thing. It basically says this resource URI from that particular customer under the plan metered billing demo video plan had a usage of 1.0 for this dimension. This is the Azure Marketplace metering name. And the effective start time is 2 o'clock in the evening. You remember we said here, this happened at 14:44. So it basically falls into the interval which starts at 2 o'clock in the afternoon. The emitter sends that API request now to Microsoft, to the Azure Marketplace Metering API. And Microsoft validates if this is a valid subscription, if you're authorized to submit usage for that subscription, and forwards it into our internal accounting system and gives us a bunch of confirmation data that we have received and acknowledged this submission, so to say. So so the emitter needs to somehow make sure that this data gets removed. The to-do item gets, crossed off the to-do list. And this happens by sending the API response from our API back into EventHub. And this is the next message which we will see now. So here, the next message is a message called usage submitted to API. And these are like the API headers which we got back from the Marketplace API and also the payload body. So this tells us the resource URI for which something was submitted, the timestamp, these values we all know from the past. These are basically our request data. The thing that we're interested in is the status is accepted. So Microsoft accepted the usage for this particular subscription. It records when this message was received by our API, which is at a few minutes before 8 o'clock in the evening UTC. It gives us a unique ID under which we track this event. And it also gives us information about the resource ID. So, little digression here into a different area. Everything which you purchase on Azure Marketplace, well, via Marketplace, like whether it is a SaaS offer or a managed application, all of these things basically have both a resource URI and a resource ID. Typically for a managed application, you would be submitting things by resource URI, like we do here. But for a SaaS offer, you could also say we submit by resource ID instead of resource URI. You have to basically pick one. Either you use the resource URI or the resource ID, and then the accelerator just does the whole thing. And so after we receive, so before we submitted it, we had an entry here in the usage to be reported. This is, so to say, our to-do list of API calls to be made. After the business logic receives this usage submitted, it basically empties the usage to be reported list again. And we can now basically see like, okay, everything's fine. So, and then we can continue to use it. And so here we effectively have a complete audit trail of everything which has been sent into Event Hub, both the message and also how the metered billing accelerator reacted to this particular event. I hope this was 40 minutes of your life spent well on this topic. Apologies for the depths, but this is really like to shed some more light on how the whole system works. Basically from sending events, making it via Event Hub and capture into the business logic, creating snapshots, emitting data to the Microsoft metered billing API, and sending the responses back so we keep track of everything. Thanks a lot for your attention. I know this was certainly the most intensive video.